This problem too is for regulars, and for the honors classes you need to find which one of these things does not represent a parallelogram. So if we look at our sets of points, maybe we start over here with D. So we go over to -6 and 0. That'll be a point somewhere around there. That's not very dark, is it? Like there. -4 and 5, somewhere in here, up to about 5. 6 and 9. 6 is here, 9 is pretty far up off the chart, maybe even. And then 4 and -4 is way down here. Well, if I connect these, I'm not seeing anything that looks much like a parallelogram, so I'm going to say that this one does not make a parallelogram, D. I can get it to work again. There. Not a parallelogram. Hey, okay, this is the trapezoid problem. I think it's number 3 on everybody's copy. Both honors and regulars have it. So for right here, what we know is this is going through the midpoint here and here, which means this piece is the same as this one, as congruent as in, okay, and this is congruent to this one. Okay, then we also know then that this is going to be the exact average of this distance and this distance. So I'm going to use my amazing little thing here, and that is going to tell me that if I took x and added it to 15 and then divided it all by 2, I would end up with, I'll get the 2, don't worry, 11, and then I'm going to just make this underlined. See, isn't this fancy? Just for you guys. Oh, good. Underline. And then down here I'll put my 2. Ha! Alright? Okay, so, but it's not really going to equal 2, it's going to equal 11. Alright, so go down here. We multiply both sides by 2, we'll find out that x plus 15 has to equal 22. From there we just have to subtract 15 from both sides. That would leave that x is equal to 7, and that would work for us. X is equal to 7. Down here on this one we have 2 diagonals of square meat, yada yada, at this point 2, 3. Midpoint formula is what we're going to use to determine, right, what that middle point is. Again, so what they're saying is they have a square, and as you know, the diagonals are going to bisect each other, and since it's a square, it's right in the middle, and we're looking for the coordinates of this point. Alright, so if you recall the midpoint formula, it's going to say that the middle of the x's is equal to x2, and I can't do this gracefully, x2 plus x1, all that, divided by 2 is going to give you the average between the two x's. Well, what we want to do down here is look what we want it to be. We want it to end up to be 2. So if we look here, if we go 4 and 4, that's going to give us 8 divided by 2, which isn't 2 because it's 4, so if that doesn't work, the others don't either. Here, -2 and 4, and that's going to be 2, and if we divide that by 2, you get 1, and that's not 2 either, so that's not your answer either. Here, if you go -4 and 8, -4 plus 8 is going to give you 4, and if you divide 4 by 2, you do indeed get 2, so that means that so far this isn't wrong because that matches this one. Okay, so now we'll look at the y's. So now we're going to go 8 and the -2. -2 plus 8 is 6, and 6 divided by 2 is 3, and 3 works. It matches that, so we know that this here is your answer right there. Okay? Cool. Hey, okay, number 5. Both regulars and honors have this problem, but I'm not sure about the numbering. Okay, so we need to find the distance of the diagonal. Diagonal means the line that goes from one vertex all the way across to the opposite vertex. Okay, and yours should be straighter than mine because you're better at this, right? Okay, so from here to here, if you count the little ticks, it ends up being that there's 5. So this from here to there is 5. If you do the same from, say, here all the way across to here, you're going to find that it's 10. So that means the diagonal can be found by using Pythagorean theorem. Well, let me just do it that way, Pythagorean theorem. Start instead of distance formula. Go away. Okay, so that means that our 5 squared plus 10 squared is going to equal the c squared, and of course this hypotenuse, which is of the triangle, which is also our diagonal, is c. So we have 25 plus 100, which is going to give us 125 as equaling c squared. Now, since I don't have a calculator handy, although I have a pretty good idea what this is, what I'm saying you can do here, you know that 9 squared would be 81. And you know that 10 squared is 100. You might know that 15 squared is 225. And you probably know that 11 squared is 121. Now 121 and 125 are sort of the endpoints for this 125, right? I mean 225. The 125 is somewhere between these two, but it's certainly closer to 121 than it is 225. That means B is your answer. It's the closest to 11 units. Now I think I'm done. Problem 6 for both classes, regular and honors. He wants to put a parallelogram in here that hits the midpoints of each of the 4 sides of the rectangle. So what we want to do is actually mark where we think the midpoints are, because actually humans are pretty good at finding the middle of something. So I'm going to put my best guess, something like that, probably around in here, somewhere up here. There maybe. Okay, now let's look at the approximate coordinates of these. To me, this one looks like it's at -4 and up a little bit. So if I check here, I've got choices of -4.5 or -4 and 0. I know down here at that intersection is totally not the midpoint because this side is way shorter than that side. So I'm going to say those are no way. If I look over here now, my choices between -1.5 or 1.5 for this point, whether it's +1 or a -1 over here, obviously it's the +1.5. So that one is this right here. So this is your answer, folks. B. I know I messed up both of them. That's it. Okay, this is problem 7 just for the honors classes, and when you first look at it, it doesn't seem as horrible as it truly is. If you notice here, point A is supposed to be at 5, -4. That will put it about here. So this can't be C. This has to be A, which of course means that this one isn't A, and it would have to be C. Okay? Alright, so they want, if we use that, then A, B, and C, D are legs. So this goes out here somewhere to some D, right? We don't know where. We don't care where, really. We'll just say D is right there for now. So that means we've got the top of the trapezoid goes over here, and the mid-segment is going to come out somewhere in the middle, about like that. You know that the mid-segment has to be parallel to the bases, so it should be parallel to both of these. And here's where you should get really confused, because this is clearly a parallel, a positive slope, and none of these are positive. But if we count the little blocks, this will go up 8 and over 3. So if we go up here and go up 8 and then go over about that many, the closest one to it is D, but we have to get rid of the negative and make it a plus there, because we know it has to be parallel to CB. And it's a lot closer to this than that, and these are ridiculous. So we cancel all those, and we take this even after the modifications. And we truly hope that the test doesn't have this kind of gross errors on it. That's it for 7 for honors. Okay, this one is number 8. I think honors and regulars have it. They show 3 vertices of a parallelogram, and they want you to find point D. Alright, so if it's a parallelogram, then whatever this slope is, it has to be the same as this slope, which means this thing's going to come up here somewhere. If you have a reasonable copy, I think that goes up to and over 5, something like that. Hang on, let me see if I can zoom in here. So it's going up 1, 2, 3, and over 1, 2, oh gosh, 4, 5, 6, I don't know how many up and over that is, but this much up, that much over, okay? On yours you can probably see it and count it. On mine, not so much, but we do know that it's going to be as parallel to that as it can get. So that's going to put it up here someplace. Alright? So, can the other point be at -1, 3? No, that would be ridiculous. What about 5, 0? Nope, equally ridiculous. 0, 7 or 0, 5? Well, they're putting it here either at 5 or up here at 7. So should it go through there more, or should it go through here more? Which one looks more accurate to you, there or there? If I could see these coordinates, I could be more exacting, but if you do an up and over count here and an up and over count, oh my god, up and over count on the top one, they need to be the same, okay? So my intuition here is that it's that one, okay? But again, I can't see them. I'm just thinking from here to here is 5, so from there to there looks about the same. Okay, so that's my intuition without actually being able to see the marks. Alright, both honors and regulars have all three of these problems. They're number 9, 10, 11 on the honors exam. They're probably different on the regulars. Okay, so if we look at this, it says one side of a parallelogram lies along the line y equals 2x plus 2. An adjacent side, that means next to it, okay? So if you have one of them here, then your adjacent one would be that one. Lies along the x-axis. If it lies along the x-axis, that means the slope of this one has to equal 0. Okay, so now they want you to find the equation of a line that could contain the side of a parallelogram that is opposite the side along the axis, which means they're looking for this one. This one has to be parallel to this one, so the slope of this one also has to equal 0. Well, let's look at our options. Here you have 2x plus 8, and if you remember your y equals mx plus b, that's telling you that mx plus 8, let me finish, can't talk and do this at the same time, that the slope of this one is 2, so 2 is not 0. The same holds here, 2 is still not 0. This x equals 6 would make a vertical line out here where x is 6, and that would be an undefined slope and definitely not a 0 slope, so that's not that because it looks like this and that's wrong. So it has to be y equals 6. Y equals 6 is indeed a horizontal line that moves along at y equals 6 somewhere up here, and it is indeed parallel to the x-axis. Okay, let's see if we can get 10 done. 10, it's a quadrilateral. Since it's a quadrilateral, all of these have to add up to 6 because the sum of the angles of a quadrilateral has to equal, I hope I said 360 degrees. Okay? Okay, so I'm going to use my wonderful tabs here, make a new one. Zing. Okay, so now all we have to do is add everything up. So we have a 90 plus a 70 plus, in parentheses, 6x plus 30, 6x plus 30. We can close the parentheses, just open them up again, and now we got to put in 2x plus 10. 2x plus 10. Okay, and all of this has to equal 360 degrees. Well, right away it would be nice to go ahead and combine our like terms. We have a 6x and a 2x, which comes nicely together as an 8x. Whoops, then that make that a plus. Now we add a 90 and a 70, that's 160, plus another 30 is 190, plus that 10 means it's going to be 200. And that, indeed, has to equal 360. Well, clearly you're going to subtract the 200 from both sides, right? Because that's what we do. Sorry about the beeping. Okay, so down here we will have that 8x has to be equal to 360 minus 200, which is going to be somewhere in the lines of 160, and we have to divide both sides by 8. And since 8 goes into 16 twice and into 0 times, that makes x 20, and you're done with that one. Wasn't that fun? Okay, let's look at this one. It's a parallelogram. Remember the song? I am a parallelogram. Yeah, I'm sure that was joyful. A, B, C. We'll call this A. That's an A, people, regardless of what you think. That's a B. That's a C. Just deal with it. It is. And that's a D. So we're talking about angles A, ABC, so that's this angle, not so much the other one. We'll get rid of that. And then again, this angle, D, is this one. Since it's a parallelogram, and we know in parallelogram that your opposite sides are congruent, you set these two things equal to each other and solve for x. So now I'm totally going to run out of time, I think. But 7x plus 30 has to equal 4x plus 45, which is going to mean that 3x has to equal 15, which means x equals 5, and I made it before this thing stopped. Yeah! Alright? Okay, that's it. This problem was the same for honors and regulars. You're going to do a dog park. It's going to start at 0, 5. There's 0, 5. Right there. 3, 1. 1, 2, 3. Somewhere around here. 5, 7. Maybe here. And 6, 5. Probably wrong about that being 7. Okay, so we're going to have this dog park. Yours will be less messy because you're not using this weird thing. Alright, but I do remember if we made a right triangle right here, that it ends up being a 3, 4, 5 right triangle. As in, this piece was 3, this piece was 4, which means that, just by counting, that this has to be 5, because you all know 3 squared was 9, 4 squared 16, 9 and 16 is 25, and of course the square root of 25 is 5. This one I think is also a 3, 4, 5, which makes that one 5 also. This one, if I recall, is 1 and I think it was 2. So 1 squared plus 2 squared is 5, so you need the square root of 5 right here. And that's going to come out to equal somewhere around 2.2, I think. Alright. Alright, then this one, how far up was that? I think that one is 2 and 5, right? So here, go ahead and use Pythagorean theorem. That was 2. 2 squared is 4. If that was 5, this is 25. So you need the square root of 29. So the things we have to add together are 5 plus 5, plus basically the 2.2, plus basically the square root of 29, which is somewhere between 5 and 6. And if we get this all together, you're going to end up with 17 and some change greater than 5. So I'll say plus or minus 2, right? I don't know. I don't remember what it is, but you have to round it anyway, and you'll get 18 yards. There you go. That's 12. Okay, this is problem number 13, and it only applies to the honor students. Alright, given that this is a parallelogram, that means that this side is congruent to this side is congruent to this side. Since they're congruent, they have the same measurements, so we can set up a set of two equations with two variables. To do this, you're kind of going to have to remember how to deal with systems of equations. I'm using the addition subtraction method, and what I'm going to do to start with is I'm going to multiply everything on the top by 5. Okay, so I'm multiplying everything here by 5, and that means I'm going to have to multiply everything down here by a -2. Why? Because I want to get rid of a 10 in there. So when I retype this, what I'll have here is that 10x plus 25y is equal to 145. Then below that, I will have that my negative 10x, see where we're going here, minus 6y is going to equal to -88. What I want to do here is that actual addition subtraction that we were talking about. I'll go right there, put that underline just to make it pretty, turn it around. Okay, these cancel out, the 10x minus 10x. However, right in here you have 25y minus 6y, which should give you 19y. So the 19y is going to equal 57. So put in 57, right? Now all I have to do is figure out what 57 divided by 19 is. So I'm going to say y is equal to 3. Okay, if y is equal to 3, now all we have to do is take that y and substitute it into one of the other equations. So we do have that 5x plus 3y, and now that we know that y is 3, we can substitute it back into there. Set that equal to 44. Right? Now we just have to finish it out. So that means that 5x plus 9 is 44. So you're going to subtract 9 from both sides. So you're going to end up with 5x is equal to 35, which means that x is equal to 7. Shazam, we're done. How about that? Of course, you would want to put them back in and make sure it works. So put them back into the equation you didn't just use. So that would mean we're going to say that 5 times 7 plus, what? 5 times 7? We already used that one. We want to say 2 times 7. My bad. 2 times 7 plus 5 times 3. We hope that equals 29. Okay? Equals something, but we do know it's 14 plus 15, and 14 plus 15 is equal to 29, and that's what we were hoping for. So right now we are totally happy. And you probably lost it, so here we go again, right there, 29. Okay, for problem 14, 15, 16, 17, they're the same for honors and the regulars classes. So we are given AB is right here, and AB is right here, right? And it is congruent to BC, which is right there. That means these two things will set congruent, and we can start with that. Okay, so the equations for those two, you're going to have that 4x plus 18 has to equal BC, which is 7x minus 6. Alright, so here let's go ahead and subtract 4x from both sides. So you're going to have 18 is equal to 7x minus the 4x, and then minus 6, and of course you can add 6 to both sides, so 24 is equal to 3x, which of course means that x is equal to, you got it, 8. So right in there you could put that x is equal to 8, and if I switch this I can put it right here, 8. Oh, that's great. Okay, erase these things, bim, 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 bim. Look at the next set. Okay, the next set has BE. BE is right here. And ED. ED is right there. Because it's a rhombus, the diagonals bisect each other, which means that BE and ED are congruent. So once again, we can use our handy dandy thing here and figure out what to do from there. So we've got 3y plus 6 has to be equal to 9y minus 6. There, that order is better. Okay, so we've got 3y plus 6, 9y minus 6. Let's go ahead and add 6 to both sides, and subtract 3y from both sides. So we're going to have 6 and 6 is 12. That's going to equal 9y minus 3y, which I believe should be like 6y. Divide both sides by 6, and you have that 2 is equal to y, which of course means that y is equal to 2 by reflexive property. So we've got that one. Alright, so that will go where y is. What about 16 finding z? Well, let's get rid of some stuff here. That. Bring this back. I said y is equal to 2, and we can put it right here. 2. Now find the value of z. Okay, for z, what do we know about z? Well, they use it right here. They're telling us that ECD is this. CD is this right here, okay? Then they're telling us that EDC right here is this one. Now since it's these are not congruent, by the way, there. Okay, since this is a rhombus, these diagonals intersect each other at right angles, which tells you that this is a right angle, which tells you that these two are complementary. They have to add up to 180. So now I use my amazing pad, and we'll go ahead and put these in. You've got 3z plus 7, and then you're going to add to that the 5z plus 3. And we said they are complementary, so they equal 90 degrees. Combine your like terms, you have, oh my, that's supposed to be a z, and you didn't say anything. Oh, some of you did. That's good. Okay, so let's go with 8z plus 7 and 3 is probably close to 10, equaling that 90 degrees. Subtract the 10 from both sides. 8z is going to be equal to 80. And yes, some of you are already thinking it. I feel you. That z is going to equal 10. Well, that was easy. Now the last thing they want you to find is the length of EC. Well, EC is given right here. Alright, let's get rid of these other things. All you have to do here is substitute. So I'm going to bring this back because I like it that well. And we're going to say that EC is 11 y minus 4. And so now we're going to go ahead and substitute in instead of y. We'll find the value of y, which we put in is 2, and then subtract 4. From here, yep, a whole bunch, you have it. You've got